In this video, we'll talk about the area of trapezoids, kites, and rhombuses. The first formula we'll encounter is the formula for the area of a trapezoid. This is 1/2 b1 times b2 times h. b1 and b2 represent the sum of the two bases of the trapezoid. The height connects the two bases at a right angle. The next formula is for the area of a kite. A kite is a quadrilateral with two pairs of consecutive congruent sides, and to find the area, we take 1/2 d1 times d2. d1 represents one of the diagonals, connecting two non-consecutive vertices. d2 represents the other diagonal, connecting the other two non-consecutive vertices. And our last formula is for the area of a rhombus. A rhombus is a quadrilateral with four congruent sides, and you can think of it as area equals base times height, where base and height have to be connected by a right angle. Or you can think of it as 1/2 d1 times d2, very much like the area of a kite, where d1 represents one diagonal and d2 represents the other. In this example, we're asked to find the area of ABCD. I can tell that this is a trapezoid based on the one pair of parallel sides marked in the diagram. My height connects my two bases at a right angle. So in this case, my height is 8. So if I evaluate 1/2 times 25 times 8, I end up with 100 square centimeters. In this next problem, we are told that the area of a trapezoid is 100 square centimeters. We are told that the height is 25 centimeters. We are looking for the sum of the lengths of the two bases. Notice that we're just looking for the sum. We don't know what the individual bases are on their own. So area of a trapezoid, we're thinking 1/2 b1 plus b2 times h. And we're going to solve for b1 plus b2. We know that the area is 100. We're solving for b1 plus b2. And we know that our height is 25. To solve this, I can start by multiplying both sides by 2 to get rid of that 1/2 fraction. I'm left with 200 equals b1 plus b2 times 25. To get b1 plus b2 on its own, I'm going to divide both sides by 25. And when I do that, I end up with 8 centimeters as the sum of b1 and b2. In this problem, we're looking for the exact area of PQRS. I see that it's a trapezoid based on the one pair of parallel sides. So I'm using the formula 1/2 b1 plus b2 times h. In this diagram, I notice that my two bases are 6 and 8. But what's missing is my height. If I take a look here and I drop down this right angle, because I know my height connects my top and bottom bases at a 90-degree angle, I notice that we're splitting this up into a 30, 60, 90 triangle. Across from 30 is x, across from 90 is 2x, and across from 60 is x through 3, based on our 30, 60, 90 right triangle pattern. Well, if I compare 6 centimeters for the top base with 8 centimeters on the bottom base, I notice that there's a difference of 2. So that must mean that x has a value of 2. And if x has a value of 2, the height is 2 times the square root of 3. So I'll plug in 2 root 3 for my height. If I multiply 1/2 times 2, that simplifies to 1. And 6 plus 8 simplifies to 14, so we're left with 14 root 3 square centimeters as the exact area of PQRS. In this problem, we're looking for the area of the figure. Based on the 4 congruent markings here, I know that I'm dealing with a rhombus. And I can think about rhombus being the area equal to the base times height, or I can think of it as the area being equal to 1/2 d1 times d2. I'm going to think about this instead because I'm given some information about the chunks of my diagonals. Now, if I remember from previous knowledge, I see diagonals in a rhombus are going to bisect each other. So that means that this diagonal here has a measure of 12 plus 12, or 24. The other diagonal, which has one piece measured at 8, the other piece must also be 8, so this entire diagonal must be 16. So if I plug in, I have 1/2 times 24 times 16, which gives me 192, and since I don't have units given, I'll just call it square units.